An average of scales. An array of scalars. And we can arrange those scalars in either a rectangular form, either vertical or horizontal. Anyhow, you can arrange them. It can be in a square form or in a rectangular form. In a square form, when the number of rows are equal to the number of columns. In the rectangular form, when they are not equal, it will form what? A rectangular form. So we can say an array of scalars usually rectangular or square form. Rectangular or square form. Full stop. Rectangular or square form. Full stop. Rectangular or square form. Full stop. The shape. The shape or dimension of a matrix is determined by the number of rows and number of columns. Likewise, the name of the matrix. So when we multiply the number of rows by the number of columns, then we use that to call that particular matrix. Who knows what a row is and what is a column? What is a row? What is a column? What is a column? What is a column? What is a row? Who can tell us? What is a row? Who can describe a row for us? Yes. What is a row? Somebody is doing like this. Like this. Is that a row? Is it like this? You are going in front. Alright. This is a row. This is a column. What is that? What do I call this? Who can describe it for us? Row. Who tell us? Rows are usually in horizontal form, and then columns are what? Columns are vertical form. Are you all here? Yes. So your ability to know how many rows a particular matrix has and how many columns a particular matrix has will tell whether you'll be able to. So thank you so much. If I draw a table this way, are you all watching? If I draw a table this way, who can tell me how many rows has this table and how many columns has this table? Somebody has just told us that rows are horizontal. Horizontal means what? From left to right or right to left. Is that what you know horizontal? Yes. Then he said the columns are vertical. Vertical means what? Top to bottom or bottom to what? Top. So who can tell us how many rows has this table and how many columns has it? Draw anything. Answer the last thing on the back. You will have the black bar. Answer me. How How many rows has this table? Who can answer that? This side. How many rows? How many rows? I can't hear you. Three rows. Are you sure? How many rows? How many rows? 3. No, you don't have 3 rows. You're walking from left to right. So what is the table? Left to right. How many boxes will you meet? Left to right. Box. This is one box. Is that it? It's another box. It's another box. It's another box. How many times am I meeting this? 4 times. We say rules. So this table has 4 rules. Now we can tell us how many columns has it? 3. The gentleman said when you move from down to top, it is what? Called a column. So how many times will I hit a box? 3. Can you all see? Yeah. So your ability to know the number of rules and the number of columns is very important in understanding this topic. Are you all here? So try your best to know that when you are given a matrix, you must be able to count how many rows are that matrix and how many columns are that matrix. When you're able to identify that, you write the number of rows first. Are you watching? You write the number of rows first, write the number of columns second, and put a cross sign in between them. That's what we are saying. The number of rows and the number of columns determine the shape, dimension, or the name of the matrix. So if you're able to know the number of rows, the number of columns, write the number of rows first, write the number of columns second, and put a cross sign in between them. They will call it 4. You know this one is the same as well. Multiply it by that. Is that what they mean? Yes. So we say 4 by 3 matrix. Can you see? So you have to know how many rows has it, how many columns has it. The rows come first and the columns come second. This is not the one saying it's a table. So let's say table. Are you all here? So this one is a 4 by 3 table. Number of rows comes first and number of columns comes second. Are you all see? Yes. So likewise, the order is just this by that. So you get 12. So the name of the matrix is the number of rows by the number of columns. And you attach the matrix to this. So you get 4 by 3 table. So let's see some few examples. We are coming to name these matrices for me. Are you all here? If this is A, this is B, this is C, this is D. Who can name this matrix for us? How many rows are this matrix? How many rows? This is a row. Can you all see? That's one. This is another row. Is another row now? No. So how many rows? 2 rows. How many columns? Are you see? This is a column. This is another column. Who's that there? How many columns? 2 columns. Are you all see? So we can call this matrix 2 by 1. 2 matrix. Can you all see? Yes. Now, you can also have 1, 2, 3. So this is a matrix also. Who can tell us how many rows has this matrix? How many rows?
1 by.
Can you see?
1 by.
Rule it out.
1 by.
From left to right. That's a rule. So rule out. How many times will you rule out from left to right? Only once. That means it has 1 rule. 1 rule. And how many times will that rule from top to down? 1, 2, 3. So how many columns?
1 by 3.
3 columns. Are you all see? Yes. Somebody say, okay. So the name is 1 by 3 can tell that. Stop writing and watch. Watch. How many rules are this matrix? You can tell us. How many rules? So if I'm moving from left to right, I'll rule. Can you see? The table. I'll move this way. 1, 2, 3, 4. How many times will you move from left to right? So I'm going 3 times. So 3 rules. Now how many colors has it got? You can tell that.
1.
How many colors?
1.
Can you see? Talk to that. Rule. When you look at it, is there any other question? No. So it has only 1 color. Any question? Any question? So you should to name every kind of matrix you see. Yes. You can write quickly. Copy that quickly. I move on. Somebody's hand is up, yes? Say, where's the question? You move on. Yeah, question you can ask. Move on. Okay. So, can you all see? This type of a single row matrix. Can you see? This type of a single row matrix. We call it row. And this one column. We call this one column matrix. These are called to row matrix. Row matrix. These are column matrix. And let's quickly look at the algebra of matrices. Addition of matrices. Addition of matrices. Addition of matrices. Kind of always talk about this one, very important. Those types of we are still young. Let me know what's like this. We don't need this information. Come up here 80 years. They dress and put your life like this. Who are you shooting off to?
Say the light.
equal to the number of columns, we'll call such a matrix a square matrix. Is it not true? If every box is equal, is it not square? Yes. Every box is equal. Like we need 2 by 2. Can you see? That's a square matrix. 2 rows, 2 columns. Can you all see? Is this a square matrix? Is it a square matrix? So that's what I said when we were dictating our matrices. We said an array of what? Scalars in either square form or what? Rectangular. So these are the only ways you can ask. When it is this way, which is not a square, it is a rectangular. Is it not a rectangular? Yes. What of this one? Is it a square matrix? No. The number of rows are not equal to what? Can you all see? Yes. So we add. So square matrices are added by adding corresponding components. Corresponding components. Corresponding components. So if you have an illustration like this, 1, 2, 3, 4, you're adding to, someone should give us a 2 by 2 matrix. 3, 4, 1, 2. So let's add them. Everybody watch. Are you watching? Everybody watch. We said we add corresponding components. So pick the first entry on the top left. Can you see? This is top left. Can you see in the first matrix? This is what? Top left, the second matrix. That's corresponding. Do you see the meaning of corresponding? Yes. Top left, top left. So you're going to have 1 plus 1, 3. And let's go to top right, 2, top right, 4. So we have what? 2 plus 1, 4. Are you all here? Yes. Then we have bottom left, 3 plus 1. The position you are picking it from, put the answer there. You get it? Yes. So bottom right, 4 plus 1, 2. Can you all see? Yes. Then what do you get? Yes, what? Any question? Any question? Copy. Yes.
Since only the square brackets you can use for the to enclose the matrix, or you can use the normal parentheses to enclose the matrix.
Let's use this one. Okay. Any other question? Always use this for matrices. Any other question?
In the exams, can you just use Victoria and add the answers? Or that
In the exam,
can you just add it and write the answers? Or that process of adding?
if I decide to give marks for field working, then you can use some marks there. So if there is time in the exam, field working. And remember, anytime you are doing your rough work, do your rough work inside where the answer booklet. Okay? So anytime in your exam you are doing rough work, do it inside the answer booklet. Don't be writing on a piece of paper. In the case of, or in a situation where you have done your rough work inside the answer booklet, then you wrote 2. The answer was 2. And when you are writing it inside your solution, you wrote -2. When I see that case, I'll consider it. Do you see that? So you have worked the thing yourself, and you had the correct answer. But in writing the answer, I wouldn't know. I'll just think you are wrong, and I'm not with that. How do you have here? So that's why they always instruct that do all of work in where you answer the question. Is it?
I said you cancel it. And you realize that it's correct again.
It is what?
You realize that what you have cancelled is correct. Cancellation cancel.
So you did write it. You only cancelled out your wrong way, not the way. That's what she asked. So let's try. Subtraction. Let's hurry up, please. Let's finish the topic. So, similarly, we subtract corresponding entries. So, if we pick an example, someone should give us a 2 by 2 matrix. 1, 0, 0, 1. Someone should give us mass. The one with mass. Diana, give us 3, 4, 4, 3. Okay, so let's do the subtraction. We said component of this is top left. Can you all see? So top left is what? 1 minus what? 3. Top right. 0 minus what? 4. Bottom left. Can you all see? 0 minus what? 4. Then bottom right. 1 minus bottom right. Minus 3. So let's see what we get. What will we get? Negative 2 and then negative 2. Thank you. So that is how we subtract. So let's quickly go up. We know it's time today. The other videos are uploaded, so they are pretty long. I think one of them has been 50% since yesterday. So still have application and sanctuary is taking so long. It's taking 2 days to upload. So 5 hours. Almost 6 hours. Scale of application. Are you finished copying the subtraction? Okay, you finished. James.
You mention it row by row or column by column.
You mentioned what?
The matrix.
Mention what? The name of the matrix.
Let's say you're giving us the matrix with these elements. So when you are calling out the elements, you call the elements out row by row or column by column.
I'm not getting you.
If you have to read out
I'm not to read out. Yeah, you go the first row and then come down second row. So here, this is what it means. Is that what it is? So if you want to read for me to write, you read 1, 2. Can you see? This is how you read it. 1, 2, 3, 4. I know that this is for left, this is for right, this is for left, this is for right. Are you okay? So 1, 2, 3, 4. If you want to write, you see I'm reading it myself. So the same way you call it out. Any other question? When you come to calculation of eye, come to eye. It means you didn't come to eye, I don't see your eye. Some of you come, you begin at that things. You concentrate. Watch my forehead. Make sure I see your face in the class. You see some of you are knowing your names already, some I don't know. I've been seeing some, I won't make you happy. You may need my help somewhere, and I'll come to pass you. So make sure I see you and I know you. By your name, by your face. What is your name? Matilda. You. What? What's your name? Joseph. Okay. So, scalar multiplication. Here, we multiply the scalar by every They say it's multiplied 2 by that. This is what we mean. So this is our scalar and this is the matrix. Can you all see? This is the scalar and this is the matrix. So the rule says multiply the scalar 2 by every component. 2 by 2, then 2 by 5, 2 by 7, 2 again by what? 9. So let's do the computation together. 2 by 2 is what? 4. 2 by 5, 10. 2 by 7,
14, 18,
2 by 9,
18.
18. Can you all see? Yes. There is no any other way this can be done. This is the only way. If you go to Germany, if you go to UK, if you go to Canada, anywhere you go, that's the same way they will teach you. The same way everywhere of that. The same thing. Mathematics is what? Exact. Everybody says mathematics is exact. What I want to teach you here is the same thing you will see inside the bush. Maybe explain it different form, but it's the same approach. Any question? Now let's see what we call equal matrices. Equal matrices or equality. There's equality of matrices. That are said to be equal, they have the same corresponding components. These matrices have the same corresponding components or entries. So these matrices have the same corresponding what? Components. Corresponding components. Please, I'm in that area. Let me close this. I'll complete my topic. No one answering now. These matrices have what? The same corresponding components. Can you see? So assuming that they give us, assume matrix A. They say matrix A is equal to matrix B. And they give us A to equal to A, B, C, T. And then they give us B to be 2, 4, negative 3, 5. They say A is equal to B. And they are saying that any matrices that are equal, they have what? The same corresponding components. Now you all see. So if A is equal to B, it implies that if they are telling us that A is equal to B, it implies that the top left is the same as what? The top left here. Can you all see? They say matrix A is equal to matrix B. And they are saying once they say some matrices are equal, it means their corresponding components are the same. The same. So if this one is A and this one is 2, it means this A can be replaced with what? 2. Can you see? So it implies that small a is what? 2. They can give you like this and say find the values of A, B, C. So this is what you do. Can you all see? Yes. So A corresponds to it. Now B corresponds to what? This one. B corresponds to what? 4. C. Bottom left. Bottom left. So C corresponds to what? C corresponds to what?
Negative
3. Then D corresponds to what? 5. So D is what? 5. So likewise, I give you C equal to D, and I tell you that C is 2x, 4, then 3, 9. And I give you D as 4, 3, 8, then to D. If matrix C is equal to matrix D, that's the second example we're looking at. If matrix C is equal to matrix D, find the value of X and Y. You can see that. So this matrix is equal to this matrix means this first entry on the top left must be equal to what? The first entry on the top left here also. So it implies that, can you all see? So it implies that 2 X is equal to what? 8. So we divide 2 by 1. So we get what? So X is what? 4. Can you all see? X is 4. What of Y? What do you compare with Y? Now you can see the top right is the same as this. Can you see? Bottom left is the same as bottom left. You cannot see? Sorry, let me write here. Let me do it bold. So they say matrix C is given as 2x or 3, 9. Then matrix D is given as 8, 4, then 3, 12, 5. Can you see now? Yes. So they are given as this, and they are saying that C and D are equal. If they are equal, it means their corresponding components are the same. So we look at where the variables are and we compare them. Can you see? Where the variables are. Because the rest of the entries are equal. Can you see? This one is the same as this one. This one is the same as this one. Can you see? The only entries are this and this. So you compare. So 2x are equal to 8. If you are looking for x, so x is what? 8 over 2. Now what do you get? 4. That's what we did. Then we come to here. This is 9 must be equal to 12. 12y. So 9 again. Since they are equal, 9 must be equal to 12y. Want y. So what do you get? Y equals to what? 9 by 12. So what do you get y to be? Y is by 3 over 4. Thank you. Can you see now? Any question? Hurry up. X is equal to 8. 2x is equal to 8. We divide 2 by 2. 2x, then 8 divided by 2. By 2. That's how much 4. You can see 8, 4. Is that what it is? Are we wrong? So 2 cancel to 1. 2 cancel 8, 4. That's what that says for. Easy. When you come here, 3. 3 goes into 9, 3 times. That's why it's 3. 3 goes into 12, 4. That's why it's 3 over 4. Can you see? It doesn't develop exactly. Goes at the back. Can you see? You can see it. So now let's see how we multiply 2 matrices. That's what you're saying. Let's see how we multiply 2 matrices. So multiplication of a matrix by another matrix. That's the next step. So we look at the determinant. Matrix by another matrix. How do you multiply the matrix by another matrix? How do you multiply a matrix by another matrix? So let me give you the rule. Let me give you the rule. Let's copy this matter for here. That's the question. Zero multiplication. Yes, if they want you to multiply, you can name it. It can be a variable or a real number. So the scalar is always outside the matrix. So I can give you matrix A. I can give matrix A. If matrix A is equal to 2, 5, 6, 7. Are you watching? If, like what you're asking, I can give a question like if matrix A is equal to this, and I'll tell you, find 3B. A is not the matrix. 3 is not the scalar. Yeah, so you see it in the question. Can you ask this one they ask? Yes. So the scalar is always what you multiply by what? The given matrix. So this is our scalar, and this is the matrix. Can you see? Yes. Any other question? The what?
The matrix beginning to the answer.
The
matrix. Like the beginning to the ask to find it.
The matrix beginning to you, and you what?
Ask to find it.
I'm not getting it.
I said that like the matrix beginning to ask to find it.
And then you do that. Okay, so that is what we do. Anytime they say that we multiply it by what, they give you matrix. So let's see. Let me give you the rule for multiplication. Now there's a rule. I watch it. Everybody watch the heads up, heads up. You see, before you can multiply a matrix by another matrix, there's a rule you must follow. Are you all here? Yes, there's a rule you must follow. And the rule states that look at the first matrix and look at the second matrix. Look at how many, or look for how many columns has the first matrix. Are you all here? So the number of columns of the first matrix must be equal to what? The number of rows of the second matrix before you can multiply that matrix. Are you aware? This time, it is not that there must be square matrices. Are you watching here? It doesn't mean there must be what? Square matrices before you can multiply them. The rule is that the number of rows of the first matrix must be the number of columns of the first matrix must be equal to what? The number of rows of the second matrix. If you are able to identify that and you see that it is satisfied, then go on to multiply. Now, there is another rule for the result after multiplying a matrix by another matrix. So you should know that before I can multiply matrix A by matrix B. So I wrote it like this: find A by B. So this is my what? My first matrix. Can you see? Is that what it? And this is my second matrix. This is what I'm talking about. Do you see? So, what is matrix again? The question: how many columns has this matrix? Look for the number of columns. And look for the number of rows of this matrix. And see whether they are equal. Sometimes I do bring questions like this in the exam. So take note of that. I can give you two matrices where you can never multiply them. So you must know the rule. If the number of columns of the first matrix is not equal to the number of rows of the second matrix, you cannot multiply it. You will struggle, you can't. I got it. Yes. So take note of that in the exam. So if this is equal to this, it means I can multiply the two matrices. But if the number of columns of the first matrix is not equal to the number of rows of the second matrix, I cannot multiply them. Are you all here? That's the rule. Now, we are saying that after multiplying your answer, how will your answer look like? Because you can also do a matrix. Is that not it? Yes. So after multiplying a matrix by another matrix, the answer must have the same box here, the same number of rows. Now you can see. Before you can multiply it, go this way. You see, columns, rows. Now the answer will have the same number of rows as the first matrix, and the same number of columns as the second matrix. Can you all see? That's the answer. first matrix must be equal to number of rows of the second matrix before you can multiply those matrices. Now, after multiplying, how will my answer or my result be? Are you already? How will my answer or my result be? Now, this is what it means. The result or answer for multiplying two matrices must have the same number of rows as the first matrix and the same number of columns as the second matrix. The number of columns of the second matrix. Restore. Of the second matrix. Restore. The second matrix. Restore. So let's make a look at two or three examples. Want to multiply? Somebody should give us 2 by 2 matrix. Joseph. 2, 4, 6, and 7. Is that what? That's it? Matilda. Okay. 3, 5, 7, 2. So what? Everybody? Hey, sorry, I didn't give you something. I didn't tell how to do your application. Sorry. Let's write it there. Sorry. Let's go. We multiply. I only told you the rules. I didn't give you the rule for multiplying. We multiply every row. Okay? We multiply every row of the first matrix. We multiply every row of the first matrix by every column of the second matrix. Are you all right? By every column of the second matrix. So that is the rule for multiplying. First, we know the rule for identifying whether or not I can multiply a matrix by another matrix. That's the first rule. The other rule also says, how will I know how my answer is going to look like? That's another rule. And this rule says, how will I multiply a matrix by another matrix? You pick the row of the first matrix. Pick every row. Pick the first row, multiply by the first column. Pick the first row again, multiply by the second column. There you come. Pick another row. Pick it, multiply. Pick it, multiply. That's all I mean by that. Are you all right? So you're coming to demonstrate that here with a few examples. Are you all see? So what? Don't write it to what? What? Okay. So we are going to multiply this matrix by this matrix. So what? Everybody? They say they multiply the matrix by another matrix. Multiply every row of the first matrix by what? Every column of the second matrix. How many rows are this matrix? How many rows? 2. Can you all see? Row 1, row 2. So pick row 1. Let's check here. How many columns are this matrix? Is it not 2? Yes. So this is row 1. This is row 2. Can you all see? This is column 1. Are you watching? This is column 2. So pick row 1, multiply by column 1. Pick row 1 again, multiply by on the column, the second on the row, the second on the column. Can you all see? That's how multiply. Row, column. First on the row, first on the column, they multiply. Second on the row, second on the column, they also multiply. Then you sum the two results. Can you all see? Yes. So we're going to pick the first on the row. On the first row is what? 2. The first on the first column is what? 3. The second is what? 4. The second is what? 2. The result, you add. It's going to replace the first position. Only the first position we have just done like that. That's the first position. If we are coming to do the second position. Can you see? So you pick this again. The same row, I said multiply first row by first column. First row again by what? Second column. So you are finished multiplying first row, first column. So multiply first row again by what? Second column. So the first on it and the first here. So you have what? 2 by what? 5. The second is 4. The second is what? 2. So we have 4 by what? 2. They put what? The plus sign in between the results. We are finished with row 1, row 1, row 1, row 2. So let's go to row 2. They say we multiply every row of the first matrix. So pick row 1, finish multiplying by every column. Do you understand the English? Multiply every row of the first column by what? Every column of the second matrix. So pick row 1, multiply by the first column, pick row 1 again, multiply by the second column. You get that? So we are going to pick row 2 again now. And multiply by the first column. So row 2, our first number here is 6, and the first here is what? 3. So multiply by 6 by what? 3. The second is 7, the second is 2. So multiply 7 by what? 2. After that, we sum them. Then, we have just multiplied row 1 by column 1. You have to multiply row 2 by column 1. So you have to multiply again, row 2 again by what? Column 2. How do I hear? So you have multiplied this way by the second. So the first here and the first here, we multiply. So what's the first on the left? 6. Now you all see. By what? 5. Then the second is what? 7. 7 by what? The second is what? 2. Can you all see? 7 by 2. Then we saw the result. Are we ready? The first one. Yeah. Yeah. So what's the one? This is 7, not 2. Hey, even we gave this 2. This is 7. Is that what I'm saying? So 2 by 3, 4 by 7. It's not 2, it's 7. I'm writing 2 here. Oh. Which one? Yeah. Because we cross it, so I thought it was number 2. So it's 7. Can you see? So this one is 7. So it's 4 by 7. Here. Is that what I'm saying? Alright. Yeah. Mine is here. Sorry, thank you. This place, so 4 by 7. 4 by 7. Can you all see? So that means here to be what? Here to be what? 7 by 7, right? Can you see? Because it's 6 by 3, 7 by the number. Can you see? So here is 7. The number is 7, not 2. So change here to what? 7. Then this one, let's cross it down. Look at 6 by 5. And then cross 7 by 2. Can you see? Yes. So let's do the simplification. 2 by 3, 4 by 7 is what? This is 8. Yes. Wow. Then 2 by 5,
10,
4 by 2,
8,
6 by 3, 7 by 7, 6 by 5, that's it. 7 by 2,
14,
14. plus 28. 21. Is it 34? 10 plus 8. 18 plus 49. 67. 30 plus 14. 44. Any questions on multiplication? Any question on multiplication? Right. Let's try and show another example before. All the time. All the time. God. 6 minutes. God, 10 good. Just want something. Give me 6 minutes. We'll finish. Okay. I'll give you some examples to go and try under here. Okay. So we'll just do the last activity. It's not difficult. Don't worry. So try. Go and try this one. Go and try this one. Multiply this matrix. You cannot see. I'll take it for you. Multiply this for me. Anyone know this matrices? Why? Because you can never have. Because number of columns, number of columns of the first matrix is equal to what? Number of rows of the second matrix. Can you all see? And how will the result be? Look at that. How will the result be? The result be what? Name the matrix. The answer. How will the answer be? It will be what? 3 by. Determinants. It's not difficult. Determinant of 2 by 2. 1 minute and we are done this one. Determinant. Whenever you are given a matrix A, B, C, D, and you find the determinant of it. Determinant is denoted by this: a straight line on the left and a straight line on the right. Can you all see? Determinant. So the determinant of a 2 by 2 matrix is found by multiplying these values of this diagonal. Can you all see? Multiply these two values of the diagonal 18. Multiply these two values of this diagonal to C, D, B, D, and B, C, and B by C, B, C. After that, find their difference. Can you all see? It's very easy. Multiply this one. Multiply this one. So this times this minus this times this. Can you all see? So let's give an example. Then 2, 3, 4, 5. So we want to find the determinant of 2, 3, 4, 5. We said multiply these two values. Can you all see? So 2 times 5. And multiply these two values and find their difference. 3 times what? 4. Find their difference. So we are going to have 2 by 5, 10. 3 by 4, 12. Yes. So what's the difference? Negative 2. That's all. About the 10. That's all. Is it? Determinants. They occur in only square matrices. No only 2 by 2. By your first context is I should teach you what 2 by 2 this semester. When you go to the second year, I'll teach you 3 by 3. Okay? So we are ending at 2 by 2. Right? Yes. So second year, Can you all see? Yes. Now, how do you find adjunct of a matrix? Adjunct of A. If A, let's use this matrix. A is what? 2, 3, 4, 5. If A is this matrix. Now let's watch how to find the adjunct of A. Adjunct of A. So adjunct of A. Everybody watch. The adjunct of a 2 by 2 matrix. Are you watching? The adjunct of a 2 by 2 matrix is obtained by interchanging these positions, these entries. Determinant will multiply these entries. Can you see? For determinant will multiply these entries. Do you see? And multiply these entries. But for inverse, for adjunct, we interchange these positions. Are you also interchange these positions? So we are going to interchange 2 and 5. Bring 2 here and put 5 here. Can you see? So bring 5 here and put 2 there. Are you all watching? That's how we find out adjunct. Adjunct. Interchange these diagonal entries. Then negate the other diagonal entries. After interchanging this and this, attack negative to this and attack negative to that. So that's a real adjunct. Can you see? So we attack negative to 3. If it was negative, it becomes positive. Is that right? Yes, positive. That's why it's becoming negative. Can you all see? So it was 3 here, it becomes negative 3. It was 4 here, it becomes what? Negative 4. It becomes negative 4. So immediately you know your adjunct and you know your determinant, you can now find out your inverse. So we are fortunate we are using the same question. So the inverse of A is 1 over the determinant. We found the determinant already. Is that what it is? What did we get? Negative 2. Negative 2, right? Times the adjunct. What's the adjunct? 5, negative 3, negative 4, 2. So you are multiplying. Multiply negative 1 over 2 by 5, negative 3, negative 4, 2. Can you see? So this one becomes our scalar. Are you all watching? That's the scalar. The legendary of Alhassan. So let's multiply. What will we get? Negative half by 5. Negative 5 over 2. Negative half by negative 3. It becomes what? Is it negative? Is it negative? Positive. So it becomes 3 over 2. Thank you. Then multiply it by this now. Negative, negative becomes what? Positive. So 4 over 2 becomes what? 2. How do I get it? Then multiply 1 over negative 1 over 2 by what? 2. How do we get? Negative 1. Negative 1. Can I believe that? So we are done. Oh, sorry. This one was a try. Where is the house? So we are done. The topic is pandemic. So